So this question actually caused quite a stir online. There's like an online forum where physics teachers, are like, "Ooh, what do we do?" This is from the specimen papers, right? And IB actually, the funny story is IB published these things, and the mark scheme that they published was just full of mistakes. So they actually published another mark scheme. They corrected all the mistakes. Um, but in this one, we were sort of like torn. How do you do this thing, right? My intuition would be that I'm going to actually make this into a sine wave, right? And it turns out, that this is roughly sinusoidal, and that the equation for this is roughly the magnetic field is roughly 1.052 plus 0.078 times 10 to the minus 2 times sine of, I'm just looking at the formula here, right? And it's 2 pi, and then whatever the time is divided by the period, which turns out to be 1 second serendipitously, right? Okay. But if you take the derivative of that, you actually get the wrong answer for this. So let's not do that, right? It's like, okay. So then the question is, how do you do this without calculus? And the answer is that what you're going to do is you're going to draw a straight line. So just go, whoa, that's really bad. Okay, let's draw a straight line there. Okay, imagine that you took a straight edge, okay, and you're going to find the slope of that line. Now keep in mind that our vertical axis is times 10 to the minus 2 teslas, right? Okay, so you're going to go, just read these points. So read off what your x's are, right? Read off your y's. Your y's are easy. You've got that and that, right? So your slope is what? y2 minus y1 over x2 minus x1. So read off these points, right? So you're going to get, plug in the numbers, right? And I got something that was, when I did that, I got a slope that was about, and remember, you got to make those things times 10 to the minus 2, which I actually didn't do and got the answer wrong. When I do that, I get a slope of 0.005148. Okay, that's what I got. There we go. Okay, and then you're going to figure this out. You're going to figure out the EMF. So the EMF is equal to minus n, and then it's really the change of flux, right, over time, right? Well, magnetic flux is just BA cos theta, right? Okay, so this becomes n, right? This becomes and our n is 240, right? So this becomes 240, right? Times this. So whatever you get for your slope, figure that out, right? Put that in there, and then our area is 2.5 times 10 to the minus 4th square meters, right? Okay, now remember that this is going to be Teslas per second, because it's the slope of a graph of magnetic field versus time, right? So that's really Teslas per 1 second. So for the time, you're going to put 1 second there, right? This is because, of course, we're not using calculus here, right? So find that slope. Show that you're finding that slope, right? Okay, find the slope. If you get something slightly off from me, I'm actually at the lower range of what they said that the permittable EMF is, right? Okay, so it's on the order, by the way, of about 0.31 to 0.35 millivolts, okay? Or 0.00031 to 0.00035, right, millivolts, okay? Happy hunting.